Welcome to Brisky Tech. Today we've got a short video to show you how to use breadboards. So in the early days of electronics, they would take electronic components and either nail or glue them down to a wooden board and then run wires between them, and that's how they would build circuits. So now we have modern breadboards, which are made out of plastic, not out of wood, but the name breadboards stuck. So we still call them that. So nowadays you can get breadboards in many different sizes, all the way from this little one here, all the way up to this gargantuan one. And they often come with adhesive, like it's basically stickers on the back that you can stick them to and you can peel off. Or they'll sometimes come mounted to these base plates that have sometimes even connectors where you can attach power supplies to them. So breadboards have a whole bunch of little holes in them, and the entire point of those holes is that you can take a wire and push it into one of those holes, and then you can attach the other end of the wire to someplace else on the breadboard. And then you can also attach electrical components, resistors, and even integrated circuits, and connect them all together. So this is the whole point of the breadboard, a quick and easy way to put together a circuit without having to solder it together. I like to use solid core wire rather than stranded wire. So that just pushes into the holes easier. So you can kind of think of it like trying to push stranded wire is kind of like trying to push a string through a small hole. It's really hard to get it to go through, but if you use a needle, which is more like the solid core wire, it's easy to push that through a small hole. Further, I like to get these breadboard wire kits. They're inexpensive and they have a bunch of different sizes of wire ready to go, and they're really handy for prototyping circuits. So I have a couple of these kits that I keep on hand just for this kind of purpose. Now you'll notice the breadboard has kind of a pattern to the holes. So the way these usually work is there's often long outside rails, which you can see here. They're often color coded. Sometimes they're even called plus or minus. So I've got basically 4 rows, 2 on the outer edges of this proto board. Usually these are used for the power buses. So you might attach your ground to the one that's marked negative. It doesn't really matter what they're marked as long as you remember which is which. And then you can attach a positive power supply, 5 volts or 3 volts or whatever, to the rail that's marked plus. And then anywhere in your circuit that you need power or ground, you can just run a short wire over to these power rails. Now the center point, it's split down the middle, and the reason for that is so that you can put an integrated circuit in a dip package across this barrier, and you can attach wires to each pin of the integrated circuit. These vertical sections are all electrically connected to each other. These 5 connection points are connected together. These 5 connection points are connected together, but they're not connected across this gap in the middle. And likewise, each column you see here is a separate, basically electrical circuit. So each column is attached to everything that's in its column, again, except for where this gap is. And any wire you connect here is going to be connected to any other wire that's connected in this column. The spacing of these columns and rows are 0.1 inches apart. So that spacing is very common for circuit boards and things like that. So you can often attach little adapter boards and things like that. They'll be the 0.1 inch size spacing. So you can just push them right into the breadboard easily. There are also these things called DuPont wires. You can get these inexpensively online from Amazon or wherever. And you can get, these are male. This side is male. So you can push those right into the circuit. And you can basically make your own little connector, just like that. And then it happens, you can get these in male and female varieties. Both ends of these are male, but you can get ones that have female ends. So if you're connecting to a board that has 0.1 inch headers, these will connect onto those. And it's male on the other end, and there's also ones that are female and female on either end. Okay, so there are some limitations to these breadboards. They're really meant to be used for fairly low voltage DC signals mostly, and low amperage. So the question comes up, what do you need to do if you want to, say, run a motor or something that takes a lot of current from a proto board? Well, or breadboard, excuse me. Usually what you want to use, and you'll see us use these a lot in this channel, is a cool little relay board like this. So what you'll do is there's screw terminals on either side of this. One side takes a low voltage control signal, which on this one is this side, and you'll just attach wires here and go between here and the screw terminals here. And that's like a control signal. And then the higher, either the AC or DC, but higher amperage stuff will attach directly to the screw terminals here, and it won't even touch your breadboard. And the reason is that these breadboards just can't handle that much current. They're just not really meant for that. And what's more is if you have a large enough gauge wire that could handle larger currents, you probably won't even be able to fit it into the holes in the breadboard, so it won't work anyway. So definitely use like a little relay board or something similar to control higher voltages and currents. Another question that comes up when you're breadboarding is, okay, so I have my circuit breadboarded, it's working, but I want to put it into like a permanent install. I want to use it in the real world. This might be a controversial answer, but I don't think you actually need to solder it down to a permanent board. We will have some tutorials coming up that will show you how to solder, because sometimes that's a really useful thing to do. But I'll say, if you're happy with your circuit and you're okay with your breadboard just being permanently installed in some device or something in your house, I think that's okay. You don't have to solder it down. But I will say, you should put it in an enclosure of some kind. And the reason for that is you don't want something metal to touch your circuit and short out a wire accidentally. Or you've seen how easy it is to insert and remove wires. You don't want something coming by and like catching on something and pulling a wire loose and then your circuit breaks. That'll make for a really bad day. So if you do want to put this into a permanent installation, put it in a box of some kind. It doesn't have to be anything fancy. It could just be an old plastic food container, cleaned out hopefully. Or it could be a fancier electronics project box or something like that. But put it in something so that you don't accidentally touch or bump the wires that are on the breadboard. Well, hopefully this helped out. Thank you for watching, and if you have any questions or comments, please leave them down below.